Okay, let us start the lecture. In the previous lecture, we have proved Steenhurst theorem, and we have also seen certain some applications of Steenhurst theorem. Now, this is the last topic of this unit: convergence in measure. Okay, convergence in measure. Convergence in measure. So again, axis mu is a fixed measure space. Okay, throughout this section, let axis mu be a measure space. You can say be a fixed measure space, be a fixed measure space. The collection of all measurable functions in X will be denoted by cursive M. Okay, the collection of all measurable, mu measurable, you can say mu measurable, collection of all mu measurable, collection of all mu measurable functions. Defined on X will be denoted by cursive M. That is, this cursive M is it's a set of functions from X to R, those functions from X to R, such that this F is mu measurable. F is mu measurable, or you can say measurable. Okay, mu measurable. So we know that this M is closed under addition, multiplication, and under also leads operation, that we already seen. It's a function space and an algebra. Okay, that we have already checked those properties of algebra and the function space. So next we have a definition. We have a new type of convergence here, that's called the convergence in measure. Definition. Then we see the properties between convergence in measure and convergence almost everywhere. First we define convergence in measure. When we say a sequence of functions converges to F in measure, a sequence Fn of measurable functions of measurable functions converges in measure you say it converges in measure to a function F, which is also measurable, to a function. That's the definition. Okay, it's from definition that that limit function is in F. Okay, converges to a function F which belongs to M, so that means it's measurable. Okay, तो यहाँ पर ये डेफिनेशन में ही है कि जो सीक्वेंस जिस फंक्शन पर कन्वर्ज करे, कन्वर्जेंस इन मेजर, जो इसकी लिमिट फंक्शन होगी विथ रेस्पेक्ट टू दिस कन्वर्जेंस, वो बाय डेफिनेशन एम में है। ओके, आपको ये प्रूव करना नहीं कि जैसे ऑलमोस्ट एवरीवेयर में हमने प्रूव किया था कि अगर एफ का लिमिट है, अगर एफ लिमिट है किसी भी सीक्वेंस का, ऑलमोस्ट एवरीवेयर लिमिट, देन दैट लिमिट फंक्शन इज आल्सो मेजरेबल। वो हमने प्रूव किया था, वहाँ पर वो प्रॉपर्टी नहीं थी उसकी। तो यहाँ पर एक्चुअली डेफिनेशन में ही है, इट शुड बी मेजरेबल, शुड बी मेजरेबल। एंड इन सिंबल्स वी राइट दिस एज, ये कन्वर्जेंस मेजर हम कैसे लिखे, इन सिंबल्स we write this as fn converges to f in major mu. Okay, it's like this. This is notation, notation of this convergence. Okay, अभी हमने इसको डिफाइन नहीं किया, अभी ये नोटेशन में लिखी है। A sequence fn of measurable functions converges in major to f measurable function f. In symbols we write this as fn converges to f in major mu if for each epsilon positive, if for each epsilon positive we have the following. We have limit n approach to infinity, the outer measure of the set mu star of the set x belongs to x such that mod of fnx minus fx greater or equal to epsilon, limit of this set, जहाँ पर ये fn minus इनके दरमियान जो डिफरेंस होगी that is greater or equal to epsilon, the limit of that set as n is approaching to infinity, this limit must be equal to 0, ये लिमिट 0 होना चाहिए, तब जाके हम कहेंगे कि fn converges to f in major mu. If for each epsilon positive this limit is equals to 0. इसके एग्जांपल्स हम लेंगे या आगे. First we prove the following theorem. Suppose we have two sequences of measurable functions. Let fn and gn be sequences of measurable functions. And let f and g be two functions which are also measurable, that's they belong to M. Then the following statements hold. Then the following statements hold. The first statement is first one. If fn converges to f in major mu, gn converges to g in major mu, then their linear combination also converges. So that means this convergence is closed with respect to the linear combination like this. This alpha fn plus beta gn, this will converge in major mu to a function alpha f plus beta g for all scalars alpha beta in the set of real numbers. So that means the convergence in major is closed with respect to this linear combination, with respect to addition, with respect to scalar multiplication. जैसे पॉइंट वाइज कन्वर्जेंस की ये प्रॉपर्टी है. सेकंड प्रॉपर्टी इसकी अब सपोज इसके दो लिमिट्स होगी इन मेजर में, किसी सीक्वेंस की दो लिमिट्स होगी तो उनके दरमियान क्या प्रॉपर्टी होगी. तो fn converges to f in major mu and fn also converges to g in major mu. दो लिमिट्स होगी with respect to this convergence. Then these two functions, these two limits must be equal to almost everywhere. That's the second property. Property 2. If fn converges to f in major mu and it also converges to g in major mu, then f must be equal to g almost everywhere. So they must be equal. They must be equal. Proof. So first we write the inequality, standard inequality that follows from triangle inequality. So we can assume that both alpha and beta are non-zero, or if they are zero, then there is nothing to prove actually. So if we assume that both alpha and beta, they are not equal to zero. Now let us see this mod of alpha fnx plus beta gnx okay, and then minus times alpha fx plus बीटा जी एक्स. एक्चुअली हमें इसी का वो ग्रेटर और इक्वल टू एप्सिलॉन लेना है, फिर उसका लिमिट निकालना है ना मेजर का, वो जीरो होना चाहिए. सो देन दिस विल कन्वर्ज टू दिस फंक्शन इन मेजर म्यू. तो सबसे पहले इसको चेक करें कि ये है क्या एक्चुअली, तो वहाँ से हमें कुछ आइडिया मिल जाएगा. दिस इज इक्वल टू मॉड ऑफ अल्फा टाइम्स एफ एन एक्स माइनस एफ ऑफ एक्स ओके प्लस beta times gnx minus g of x. Now we can apply triangle inequality. This thing, it's less or equal to mod of alpha times mod of fnx minus f of x plus mod of beta times gnx minus g of x. So it means that whenever the right hand side of this inequality is greater than epsilon, then its left hand side will also be greater than epsilon, because the left hand side is greater or equal to the right hand side. So that easily follows. So whenever this one, okay, ये जो है ना ये, if this is greater or equal to epsilon, this अगर ये greater or equal to epsilon होगा, then this one alpha times this plus beta, it will also be greater or equal to epsilon, because it's greater or equal to that one जो जहाँ से आपने स्टार्ट किया इस inequality को. So therefore it follows that इस inequality का यूज करना है हमें. Therefore it follows that the set x such that mod of alpha fnx plus beta gnx then minus times alpha fx plus beta gx greater or equal to epsilon this set. So whenever this is true, then this will be subset of the set x belongs to x such that mod of fnx minus fx greater or equal to epsilon divided by 2 times mod of alpha. Okay, this set union this x belongs to x, set x belongs to x such that mod of gnx minus g of x is greater or equal to epsilon divided by twice mod of beta. So it's subset of the set of these two, union of these two sets. So this is simple. Suppose x is here, then obviously this is greater or equal to epsilon, but it implies that that sum of the modulus will also be greater or equal to epsilon. So that means at least one of them must be greater or equal to epsilon. So either this or at least one of them must be greater or equal to epsilon by 2, because if both are less than epsilon by 2, then sum will also be less than epsilon by sum will be less than epsilon, but which is not the case because sum is greater or equal to epsilon. तो इसको आप चेक कर सकते हो, दिस यू कैन वेरीफाई. So let's इसका मैं नाम स्टार रख दूंगा. Let's verify this star. It's subset of this union. Okay. So this verification of star. Okay. Let's try to verify it. Verification of star. So suppose say y belongs to the set x such that mod of alpha fnx plus beta gnx, then minus times alpha fx plus beta gx, okay, is greater or equal to epsilon. Suppose y is there, y is in this set. This means that it satisfies this inequality, this y. This means that f and y, alpha times f and y, its modulus, okay, plus beta times g and y minus times, okay, it's not modulus here, so it's this minus times alpha fx plus beta gx is greater or equal to epsilon. But then जो आपने अभी वो जो इनइक्वालिटी आपने लिखी ना पहले, वहाँ से क्या आ जाएगा, वहाँ से आपके पास ये आ जाएगा अल्फा टाइम्स मॉड ऑफ एफ एन एक्स माइनस एफ ऑफ एक्स प्लस बीटा टाइम्स मॉड ऑफ जी एन एक्स माइनस जी ऑफ एक्स. So you can write here if and only, okay, if and only, not we don't need if and only. यहाँ तक तो था if and only, but आगे शायद नहीं आ जाए if and only. It's not if and only, okay. So this sum of this modulus, okay, it's mod of alpha times, okay, mod of alpha, it's mod of beta. This is greater or equal to epsilon, but it implies that at least either this is greater than epsilon by 2 or this one is greater than epsilon by 2, because in case if both are less than epsilon by 2, suppose ये भी less than epsilon by 2 होगा, ये भी less than epsilon by 2 होगा, तो इनका sum जो होगा ना वो less than epsilon होगा, but the sum is greater or equal to epsilon. So this means that mod of alpha times mod of fnx mod of fnx minus f of x greater or equal to epsilon by 2, or mod of beta times mod of gnx minus gx greater or equal to greater than epsilon by 2, greater or equal to epsilon by 2, okay, greater or equal to epsilon by 2. These are this. Then it implies that we can divide by mod of alpha and mod of beta, because it's a positive number, it's a non-zero number, as alpha is not equal to 0 and beta is not equal to 0. So it implies that this mod of fnx minus mod of fx is greater or equal to epsilon by 2 is mod of alpha. Okay, it's not here x, it's actually y, okay, it's y, it's not x. हमने y एलिमेंट लिया ना उसमें, it's y here. It's y, okay, y, it's not x. Okay, so this implies that mod of f and y minus f of y is greater or equal to epsilon divided by twice mod of alpha, or mod of g and y minus g of y is greater or equal to epsilon divided by 2y mod of beta. So this implies that it's y either satisfies this inequality or satisfies this inequality. That means y belongs to the union of these two sets. X belongs to x such that mod of fnx minus fx greater or equal to epsilon divided by 2y mod of alpha union x belongs to x such that mod of gnx minus g of x greater or equal to epsilon divided by 2y mod of beta. ये इनका union. So that means whenever y was chosen in that set, then y belongs to this set. So which implies that the set is subset of this union. It is subset of the union. So therefore this star gives, star से हमें क्या मिलेगा? Star gives new star of the set. Okay, जो आपके पास set है x belongs to x such that mod of alpha fnx plus beta gnx minus times alpha fx plus beta gx modulus greater or equal to epsilon, the measure of this set. Okay, measure of this set greater or equal to epsilon is here. It's greater or equal to epsilon. Okay, set this modulus greater or equal to epsilon, then we have a set bracket. Mu star of this, it will be less or equal to the mu star of union, and you can apply the additive property. It will be less or equal to mu star of the first set plus mu star of the second set. So it's less or equal to, it's less or equal to mu star of the set x belongs to x such that mod of fnx minus fx greater or equal to epsilon divided by 2y mod of alpha plus mu star of the set x belongs to x such that mod of gnx minus gx greater or equal to epsilon divided by 2y beta. Okay, but this fn converges to fn major, so that means limit of this is 0 for each epsilon first two, and here epsilon is epsilon by 2y mod of alpha, and also gn converges to gn major, so therefore limit of this set is also 0. So let's apply the limit on both sides. This gives that limit n approach to infinity mu star of the set x belongs to x such that mod of alpha fnx plus beta gnx then minus times alpha fx plus beta gx greater or equal to epsilon. This limit is less or equal to limit of this, but this is 0 as fn converges to f. You know, आपने ऊपर लिखा ये these two sums. It's less or equal to 0 plus 0, less or equal to 0 plus 0, that's equal to 0. But it can't be less than 0, that means it's equal to 0. This means limit n approach to infinity mu star of यही same set लिख दीजिए जो आपने लिखा ना, mu star of this set, this is equal to 0. तो ये 0 आ गया. इसका मतलब क्या है? इसका मतलब ये है कि अल्फा एफ एन प्लस बीटा जी एन कन्वर्जेस टू अल्फा एफ एन प्लस बीटा जी एन कन्वर्जेस टू अल्फा एफ प्लस बीटा जी इन मेजर म्यू. So it implies that alpha fn plus beta gn converges to alpha f plus beta g in measure mu. In measure mu. Okay, second part. Okay, so assume that Fn converges to F in major mu, and Fn same sequence, Fn converges to G in major mu. Suppose that this is true. Now given epsilon positive, given epsilon positive, we have this we have this thing. We have mod of fx minus gx is lesser equal to, by applying triangle inequality, let us introduce fn plus fn and minus fn. It will be lesser equal to fnx minus fx, okay, plus mod of fnx minus gx by triangle inequality. So if it's greater or equal, so let's start with this twice epsilon, greater or equal to epsilon. So this thing 2 epsilon, given epsilon we have 2 epsilon. Oh, let's do it right here, 2 epsilon. Yes, fx minus gx, okay. It's fnx minus fx and then fnx minus gx. So actually you can do like this. मैं इसको पूरा लिख दूंगा ताकि इसमें कोई confusion ना रहे आपको. Let's write it like this. This is equal to fx. Sorry, it's mod here. Let's start with mod. Fx minus fnx plus fnx minus gx. Now let's separate triangle inequality. It's lesser equal to mod of first plus mod of second, but mod में हम इनको change कर सकते, okay? It's mod of fnx minus fx plus mod of fnx minus gx. So therefore if this अगर ये जो है ना ये मॉडुलस, if it's greater or equal to epsilon 2 epsilon से, अगर ये greater or equal to 2 epsilon होगा, then at least one of the modulus is greater or equal to epsilon. कम से कम एक greater or equal to epsilon. So it means that this set x belongs to x such that mod of fx minus gx greater or equal to epsilon. It is the union of these two sets. It's subset of the union of the sets x belongs to x such that mod of fnx minus fx greater or equal to epsilon union x belongs to x such that mod of gnx minus fx greater or equal to epsilon. ये इसका सबसेट होगा, ओके ये जो सेट होगा ये इसका सबसेट बाय यूजिंग दिस इनइक्वालिटी जो हमने ऊपर ट्रायंगल इनइक्वालिटी लिखी है. यू कैन इजीली वेरीफाइड. आप लीजिए इसमें कोई पॉइंट आपको ऑब्वियसली वो इन दो सेट्स में से किसी ना किसी सेट में आ ही जाएगा वो पॉइंट, जैसे अभी हमने वो इसका एक्सप्लेन किया था फर्स्ट पार्ट में. इट्स सेम, ओके. बट दिस लिमिट अगर आप देखो ना इसका मतलब है कि म्यू स्टार ऑफ द फर्स्ट सेट दिस इज इट इज लेसर इक्वल टू म्यू स्टार द sum of these two sets because mu star is a sine sigma sub additive and we also applying the monotone property of mu star actually. So this gives mu star of the set x belongs to x such that mod of fx minus gx greater or equal to epsilon for any two epsilon positive. This is it's lesser equal to mu star of the first set x belongs to x such that fnx minus fx, its modulus, is greater or equal to epsilon plus mu star of the set x belongs to x, such that mod of gnx minus gx greater or equal to epsilon. So by letting n approach to infinity, this sum is 0 because this is also 0 as fn converges to f almost ever, and this one, second one, it's also equal to 0 because, sorry, it's fn, it's here fn, okay, it's not gn. So you can see same actually, but the limits are different, okay. So you can see same. तो ये दोनों अप्रोच करें जीरो को बिकॉज एफ एन कन्वर्जेस टू एफ इन मेजर एंड एफ एन आल्सो कन्वर्जेस टू जी इन मेजर म्यू, so which means that the mu star, by letting n approach to infinity, this side is 0, therefore this must be equal to 0. Mu star of the set x belongs to x such that mod of fx minus gx greater or equal to 2 epsilon, this is equal to 0 for all epsilon positive. So this thing is equal to 0. तो इस सेट का मेजर 0 है फॉर ईच एप्सिलॉन पॉजिटिव, बट हमें चाहिए कि दे आर अनइक्वल, दे आर इक्वल ऑलमोस्ट एवरीवेयर, दे आर इक्वल ऑलमोस्ट एवरीवेयर। तो उसके लिए हमें उस सेट का मेजर चाहिए एक्चुअली जहाँ पर ये इक्वलिटी नहीं हो, वो कौन सा सेट होगा। तो दिस इम्प्लाइज द म्यू स्टार ऑफ द सेट एक्स such that fx not equal to gx, ये जो सेट होगा fx not equal to gx, ये क्या होगा, दिस विल बी the mu star, ये जो set होगा ना, this set is the union of the following sets, you can easily verify it. This is equal to the union and runs from 1 to infinity, union of these sets x belongs to x such that mod of fx minus gx is greater or equal to 1 by n, it's union of these sets. But for each epsilon positive, fx minus gx greater than epsilon, here 1 by n is also a positive number. So for each positive number, the mu star of each set is 0 actually. First you apply the sub-additive property. This is less or equal to summation n runs from 1 to infinity mu star of the x belongs to x such that mod of fx minus gx greater or equal to 1 by n. तो आपने अभी प्रूव किया ना, फॉर ईच एप्सिलॉन पॉजिटिव इफ मॉड ऑफ fx minus gx is greater or equal to epsilon, then the measure of that set is always 0. So here epsilon is equal to 1 by n, it is also a positive number, so this is equal to say 0 plus 0, that's equal to 0. So that means the set where fx is not equal to gx is 0, इसका measure 0 है उस set का measure, it means that f must be equal to g almost everywhere, they are equal almost everywhere. They are equal almost everywhere. Okay, next theorem. So next theorem is if a sequence fn of measurable functions, if a sequence fn of measurable functions, if a sequence fn of measurable functions satisfy this, fn converges to f in measure mu, then fn plus converges to f plus you know maximum of fn 0, okay, in measure mu, and this fn minus will also, fn minus converges to f minus in measure mu, and finally this thing mod of fn converges to mod of f in measure mu, okay. तो इसका प्रूफ आपके लिए असाइनमेंट है. तो प्रूफ इज असाइनमेंट. और अगर आप एलप्रिंट से इसका प्रूफ देखना चाहोगे, इट्स एट पेज नंबर 147. तो वहाँ पर इसने एक इनइक्वालिटी यूज़ की, वो इनइक्वालिटी आपको वेरीफाई कर दी है. रेस्ट ऑफ द प्रूफ इज सिंपल. इट्स अ वन लाइन प्रूफ एक्चुअली. तो सिर्फ आपको वो इनइक्वालिटी चेक करनी है, वो इनइक्वालिटी. तो वो इनइक्वालिटी ये है जो मैं यहाँ पर आपको बता दूंगा. वो इनइक्वालिटी आप देख लीजिए. एफ एन प्लस माइनस एफ प्लस, आपको ये चेक करना, दिस इज लेस आर इक्वल टू मॉड ऑफ एफ एन माइनस एफ. इसी तरह से एफ माइनस के लिए भी ट्रू है और एफ प्लस के लिए भी ट्रू है. और एक इनइक्वालिटी है जो कि मॉडलेस के लिए है, जो कि एक्चुअली आपने बहुत सी जगहों पर यूज़ भी किया होगा. मॉड ऑफ एफ एन माइनस मॉड ऑफ एफ इज लेस आर इक्वल टू मॉड ऑफ एफ एन माइनस एफ. तो तीन इनइक्वालिटीज है, एक तो प्लस के लिए है, दूसरी माइनस के लिए है, और तीसरी ये वाली इनइक्वालिटी है मॉड ऑफ एफ एन माइनस मॉड ऑफ एफ लेस आर इक्वल टू. ये इनइक्वालिटीज आप वेरीफाई कीजिए, यू विल गेट दिस थ्योरम. So next theorem is the relationship between the convergence in measure and convergence almost everywhere. And convergence almost everywhere. So this is the theorem. If a sequence fn of measurable functions, if fn is a sequence of measurable function, is a sequence of measurable functions such that fn converges to f in measure mu. So obviously this f is measurable, okay, by definition. Then there exists a subsequence. There exists a subsequence fkn. Okay, fkn, k then sub n, okay, kn of the sequence fn such that fkn converges to f almost f. मतलब सब सीक्वेंस एक्सिस्ट होगी, पूरी सीक्वेंस कन्वर्ज नहीं करेगी ऑलमोस्ट एवरीवेयर. और इसके लिए हमें एक काउंटर एग्जांपल है. वी हैव अ सीक्वेंस ऑफ फंक्शंस व्हिच कन्वर्जेस टू f इन मेजर म्यू, बट fn डज नॉट कन्वर्ज टू f एट एनी पॉइंट. किसी भी पॉइंट पर कन्वर्जेंस नहीं हो रही है. ऑलमोस्ट एवरीवेयर तो दूर की बात है, किसी भी पॉइंट पर पॉइंट वाइज कन्वर्जेंस नहीं है, बट स्टिल fn कन्वर्जेस टू f इन मेजर म्यू. ओके, उसकी हम एग्जांपल देंगे. बट हियर वी कैन ऑलवेज कंस्ट्रक्ट ए सबसीक्वेंस फ्रॉम द सीक्वेंस fn व्हिच कन्वर्जेस टू f ऑलमोस्ट एवरीवेयर. दैट्स ट्रू. दैट्स दिस थ्योरम. Okay, proof. So since this fn converges to f in major mu, so therefore for all epsilon positive we have this limit and approach to infinity mu star of the set x belongs to x such that mod of fn x minus fx greater or equal to epsilon is equal to 0. इसका measure 0 limit. This is the definition of convergence in measure mu. Okay. So for let's take, अगर हम एप्सिलॉन के वैल्यूज देंगे 1, 1/2, 1/3, ओके, हर किसी के लिए ये ट्रू होगा ना, फॉर ईच एवरीथिंग इट्स ट्रू. So it's true for each epsilon positive. So it means that this implies that limit and approach to infinity mu star of this set x belongs to x such that mod of fn x minus fx greater or equal to 1. This limit is also equal to 0. And the second limit ये भी मैं 0 ले सकता हूँ. Limit and approach to infinity mu star of x belongs to x such that mod of, मैं यहाँ पर थोड़ा ये elaborate कर रहा हूँ आपके लिए. It's not like this actually. 1/2. This limit is also equal to 0. So continue this process. We have this limit and approach to infinity mu star of the set x belongs to x such that mod of fn x minus fx, okay, minus fx, or you can write here say greater or equal to 1/m or greater or equal to 1/n. You can also take greater or equal to 1/n, so no problem. It's 1/n. 1/n is also positive number, so for each epsilon positive, for this n, then we can take the limit and approach to infinity. This is also equal to 0. So this limit is equal to 0. This limit is equal to 0 means that we can from this we conclude that the limit is 0. So we can say this is less than some epsilon. For each epsilon positive, we can find a natural number n such that this mod of this thing is less than epsilon. क्योंकि limit है ना, limit approach to 0. Limit of this is approaching to 0. It's a non-negative actually, so we don't need to mod here now. Mu star ये actually अगर आपके पास ये होगा ना, limit of an is equal to 0, इसका मतलब क्या है? For all epsilon positive there is some n such that mod of an minus 0 is less than epsilon for all n greater or equal to n. तो अगर ये नॉन नेगेटिव ही होगा, आपको मॉड लिखने की ज़रूरत नहीं है. We can simply write an is less than epsilon. For each epsilon positive, we can find n. So let's choose here epsilon now. We can choose epsilon equal to 2 power minus n. For this value of epsilon, there exists say some natural number, some kn. Let's denote that capital N by kn, because obviously this capital N, it depends on epsilon. For each epsilon positive, I can find n, but that n depends on epsilon. So if I choose epsilon equal to 2 power minus n, then for this value of epsilon, I can also find a natural number, and let's denote that natural number by kn, okay, such that mod of an is less than 2 power minus n for all n greater or equal to kn. ये है. अगर ये नॉन नेगेटिव होगा तो आपको मॉड की ज़रूरत नहीं है. और इस केस में आपके पास क्या है? आपके पास लिमिट ऑफ म्यू स्टार है. Mu star is always non-negative, so it's a sequence of non-negative real numbers, so we don't need to write mod here. So what can we do? We can find, so there exists a strictly increasing sequence, a strictly increasing sequence, जैसे ग्रेटर इक्वल टू 1 के लिए भी है ना, लिमिट इक्वल टू 0, वहाँ पर भी आपको कोई नेचुरल नंबर k1 मिलेगा लिमिट के लिए. इसी तरह से ग्रेटर इक्वल टू 1/2, वहाँ पर भी वो लिमिट अप्रोच टू 0 कर रहा है. तो हर जगह लिमिट इज अप्रोचिंग टू 0, तो हर जगह आपको कोई ना कोई नेचुरल नंबर मिलेगा. जब आप ग्रेटर इक्वल टू 1 करोगे, वहाँ पर आप नेचुरल नंबर k1 लोगे. जब आप ग्रेटर इक्वल टू 2 करोगे, वहाँ पर आप नेचुरल नंबर k2 लोगे. और ये जो सीक्वेंस होगी ना, ये स्ट्रिक्टली इंक्रीजिंग सीक्वेंस आ जाएगी. k1 मस्ट बी स्ट्रिक्टली लेस देन k2. तो ये सीक्वेंस आपको मिल जाएगी. देयर एग्जिस्ट्स ए सीक्वेंस ऑफ स्ट्रिक्टली इंक्रीजिंग. अगर ये स्ट्रिक्टली, सपोज आपके पास ये है k1 तो आपको मिल गया फर्स्ट केस में, k2 अब आपको k2 फॉर ऑल n ग्रेटर इक्वल टू k2. So suppose this k2 is less than k1, हमें strictly increasing चाहिए, but since this अगर ये k2 less than k1 होगा तो मैं k2 को बढ़ाऊंगा, because I want this actually for all n greater or equal to k2 I can replace this k2 by any number which is greater than k2. तो मैं k2 से बड़ा कोई नंबर चूज करूंगा. I will choose a number, that number such that that number is greater than k1, so that I can do. So I can find this strictly increasing sequence kn. So k1 less than आपके पास इस तरह से k1 less than k2 less than k3 less than k4, इस तरह से आपको सीक्वेंस मिल जाएगी. ये k1 कहाँ पर मिलेगा आपको, जब आप ये वाला लोगे, लिमिट n अप्रोच to infinity mu star of this set x such that mod of fn x minus fx greater or equal to 1, this limit equal to 0. तो जब ये लिमिट 0 होगा तो हर किसी एप्सिलॉन पॉजिटिव के लिए आपको कोई ना कोई नेचुरल नंबर मिलेगा. तो एप्सिलॉन पॉजिटिव यहाँ पर क्या लोगे आप, 2 power minus 1 in that case. For this value of epsilon I can find a natural number. Let's note that by q. ओके इसी तरह से आपके पास दूसरा लिमिट आपके पास लिमिट n अप्रोच टू इन्फिनिटी म्यू स्टार ऑफ x मॉड ऑफ fn x माइनस fx ग्रेटर और इक्वल टू 1/2. तो इसके लिए भी हर किसी एप्सिलॉन के लिए आपको कोई ना कोई नेचुरल नंबर मिलेगा. सो यू कैन चूज एप्सिलॉन टू बी 2 power minus 2 and that natural number you choose that natural number k2. तो ये k1 k2 की सीक्वेंस आपको मिलेगी और ये इंक्रीजिंग सीक्वेंस आप चूज कर सकते हो. अगर ये इंक्रीजिंग सीक्वेंस ना भी होगी यू कैन चूज इंक्रीजिंग सीक्वेंस. So there is a strictly increasing sequence kn, okay, kn of natural numbers okay, such that this म्यू स्टार ये आपके पास सीक्वेंस है जिसका आप लिमिट लेना है, लिमिट है x belongs to x such that mod of fn x minus fx lesser equal to 1/n. this इसका मॉड लेने की जरूरत नहीं, इट्स लेस देन एप्सिलॉन, एप्सिलॉन इज 2 power minus n for all n greater or equal to kn. Okay, so अब क्योंकि ये n आप दोनों जगह ले, it will create confusion here. So I should write here fk, okay, instead of fn. fk I should write here k greater or equal to kn. k, okay, fk, where this k it's greater or equal to k. Okay, now we can define a set en. So put en is equal to, based on this inequality we can define a set en, those points such that mod of f k and x minus fx greater or equal to 1/n. greater, sorry it's not less or equal, it's greater or equal to, मैंने greater लिखा है, मैंने less लिखा है, it's greater or equal to here. Okay, it's greater or equal to, okay, this thing is greater or equal to 1/n. Okay, for each n you can define this for each n. So this set is obviously non-empty because you can see above that we have a set, we have mu star x belongs to x such that fkx minus fx greater or equal to 1/n is less than 2 power minus n. So for all k greater or equal to kn, so in particular it's true for k equal to kn also. तो वहाँ पर आपको क्या मिलेगा, mu star of the set x belongs to x such that fknx minus fx greater or equal to 1/n. The mu star of this set is less than 2 power minus n. So we can define sets like this. For each n we define this set, and let's define now E and define the set E. Define E, and we define E by, what's this E? What's this set E? It is the intersection m runs from 1 to infinity. Okay, then union n runs from m to infinity of ens. It is intersection of unions. Okay, then since each en is measurable, because fn is measurable, fkn is measurable, fx is measurable, so each en is measurable. Since each en is measurable, as fn and f are measurable functions, they are actually measurable functions for all n greater or equal to 1. So therefore अगर ये हर कोई en measurable है, therefore e is measurable, therefore e is measurable, because collection of measurable functions is sigma algebra. E is measurable. Now let's find its outer measure. We will see that its outer measure is actually equal to 0, so it's actually a null set. Now what's mu star of e? It is the mu star of the intersection for m runs from 1 to infinity. So for each intersection will be subset of the set actually. So I can write this is less or equal to mu star of the union. Mu star of union n runs from m to infinity. Okay, en for all m greater or equal to 1. Now I will explain it here. So suppose m is equal to 1. अगर m okay m अगर 1 के बराबर, उस केस में क्या होगा? Its intersection m runs from 1 to infinity, then union n runs from 1 to infinity. Okay, तो इंटरसेक्शन कहाँ से स्टार्ट हुआ? 1 से. अगर m 1 के बराबर होगा, तो अगर m 1 के बराबर आपके पास होगा, सो इट्स अ सिंगल इंटरसेक्शन, क्योंकि m आपने 1 लिया है तो ये सिर्फ यूनियन रहेगा. उस केस में e मतलब e इस यूनियन के बराबर होगा. यूनियन n रनस फ्रॉम 1 टू इन्फिनिटी n, तो उस केस में तो इक्वलिटी है, तो मेजर भी इक्वल हो जाएगा. बट इन केस m इज इक्वल टू 2, तो आपको यूनियन करना स्टार्ट कहाँ से? 2 से लेकर 2 टू इन्फिनिटी, where this m runs from this m is equal to 2. So what can we do? M is equal to 2. It's m runs from 1 to infinity. Okay, तो m का वैल्यू 2 तक आपको लेना है. इट्स इंटरसेक्शन ऑफ 2 सेट्स. So first you choose the first intersection. First union is n runs from 1 to infinity, and the second union is n runs from 2 to infinity. So it is the intersection of 2 sets. So first is the n runs from 1 to infinity, and the second is n runs from 2 to infinity. दो unions है ये, and e is equal to the intersection of these two unions. So it means that e is subset of both the intersection, both the unions. E is subset of both unions. तो वही एक्चुअली आ रहा है e is subset of. तो आप यहाँ से ये कंक्लूड कर सकते हैं, e is subset of the union e n. अगर आप यहाँ पर लिखोगे भी ये n runs from m to infinity for all m greater or equal to 1. It is intersection of unions. That means e is subset of each union. हर जो भी यूनियन इंटरसेक्शन में है, हर किसी यूनियन का e सबसेट है. ओके, m runs from 1 to infinity, तो n runs from 1 to infinity का भी सबसेट है, n runs from 2 to infinity का भी सबसेट है, n runs from 3 to infinity का भी सबसेट, बिकॉज इट्स द सबसेट ऑफ ऑल सच इंटरसेक्शंस. एक्चुअली ये जो इंटरसेक्शंस आपको मिल रहे हैं ना, पहला इंटरसेक्शन में पहला सेट कौन सा है? n runs from 1 to infinity. सेकंड कौन सा है? n runs from 2 to infinity. थर्ड कौन सा है? n runs from 3 to infinity. ऐसे सेट्स का ये इंटरसेक्शन है e. So e must be subset of each set. In other words, I can see each union. E is subset of each union. So that's why I have written here this mu star of e is less or equal to mu star of the union for all m greater or equal to 1. Okay, so then I can apply the sub-additive property here. So it's less or equal to summation n runs from m to infinity mu star of en. But what's mu star of en? It's equal to summation n runs from 1 to infinity mu star of en is 1 by 2 power n, or you can say 2 power minus n. It's 2 power minus n, I think. Yes, 2 power minus n. Okay, not strictly less than, in fact, strictly less than. Okay, 2 power minus n. So this is equal to n runs from m to infinity. It's 2 power minus m plus 2 power minus times m plus 1 plus so on and so forth. So it's a geometric series with first term 2 power minus m and the common ratio is 1 by 2. So it's a divided by a is 2 power minus m divided by 1 minus r is 1 by 2. So that's equal to 1 by 1 minus 1 by 2, it's again 1 by 2. So it's 2 times, it's 2 power minus m plus 1 for all m greater or equal to 1. So mu star of E is lesser or equal to 2 power minus m plus 1. Mu star of E is lesser or equal to 2 power minus m plus 1 for all m greater or equal to 1. So it means that this mu star of E is lesser or equal to 2 power minus m plus 1 for all m, okay, for all m. Letting m approach to infinity, this means that mu star of E is equal to 0. तो नल सेट आपको मिल गया. एक्चुअली आपको प्रूव करना है f कन्वर्जेस दिस द सबसिक्वेंस f के n कन्वर्जेस टू f ऑलमोस्ट एवरीवेयर. तो हम प्रूव करेंगे e कंप्लीमेंट में जो है ना आपके पास सबसिक्वेंस f के n, क्योंकि आपने k n एक सीक्वेंस निकाली है ना k1 k2 kn, उस सीक्वेंस के रेस्पेक्ट में आप fn के सबसिक्वेंस निकालोगे f k1 f k2 f k3 so on and so on, and you will see that that subsequence converges on e complement पर वो कन्वर्ज कर रहे हैं. So that means that sequence may not converge on E, but it always converges on E complement. तो सिर्फ null set पर converge नहीं कर रही है वो subsequence. That means the subsequence converges almost everywhere. वो हम check करेंगे. So now if x is not in E, we will see that f can converges to f on at that point. If x is not in E, so that means x is not in the intersection m runs from 1 to infinity union n runs from m to infinity en. तो इंटरसेक्शन में नहीं है, इंटरसेक्शन ऑफ यूनियन इसमें, तो किसी एक m में नहीं होगा. So that means x does not belongs to union n runs from m to infinity en for some m, किसी एक m के लिए. अब ये यूनियन में नहीं है, तो यूनियन में नहीं होने का मतलब क्या है, किसी भी सेट में नहीं है. x is not in en for all n greater or equal to m, where m is some fixed positive integer. x इसमें नहीं है, x इसमें अगर नहीं है तो इसका मतलब क्या है, इसका मतलब ये है कि मॉड ऑफ f के n x जो ना en की डेफिनेशन है माइनस fx. en की डेफिनेशन है कि दिस इज ग्रेटर और इक्वल टू 1 by n, बट इट्स नॉट इन en, इट मीन्स दैट इट्स लेस देन 1 by n फॉर ऑल n greater or equal to n. So that means f can converges to f for all that means f can converges to, because it's true for all n greater or equal to m, so that means f can converges to f. So which implies that fkn converges to fx. Okay, so therefore this subsequence fkn x converges to fx for all x not in e. e के बाहर कन्वर्ज कर, e में कर रहा है कि नहीं कर वो हमें पता, बट e के बाहर इट कन्वर्जेस. और मगर e का मेजर क्या है, e का मेजर 0. इट मीन्स दैट f can converges to f almost everywhere. ओके, अब आप अपने अगर किसी को कोई कन्फ्यूजन है तो वो बता सकता है. एनी कन्फ्यूजन इफ यू हैव इन दिस टू थर्म्स.
सर हमें सीआई के लिए क्या पढ़ना है, कौन सा है?
हाँ, सीआई के लिए आप स्टीनर्स थ्योरम तक जो आपने किया है ना,
जी सर.
अप टू स्टीनर्स थ्योरम. पहला यूनिट हमने सारा किया था ना, तो मेजरेबल फंक्शन से आपको स्टार्ट करना है स्टीनर्स थ्योरम तक.
सर उसमें थोड़ा सा है ना वो थर्ड फोर्थ यूनिट का स्टेप फंक्शन।
हाँ वो करना है, वो आपको करना है इसमें, वो आपको करना है इसमें।